Okay, this is question 1 out of the 3 questions, and this question relates to the equation r equals a plus b sine theta. So I am tasked with analyzing what this means and what the equation tells us. So this is the standard Limason equation, though it can also refer to circles. I'll get into that a little bit later. And looks like that. So the r value of this equation is the distance away from the pole of any value that's generated from theta. So if you plug in a value for theta, you will get an r value through this equation, and that is the distance away from the pole. So putting them together gives you the polar coordinates. The a value is the distance away from the pole of the polar intercepts. So the majority of the Limasons have 2 polar intercepts, and the a value is the distance away of each of those intercepts. And for b, this value is a little bit different because it's usually 2 intercepts on the Limasons, but not always. Sometimes there is a 3rd intercept, and you kind of just ignore that. That's on the Limasons with inner loops. And I misspoke with the a value. It's only 1 point on circles, not Limasons. So those are the key elements of the equation, and of course theta is a value you just plug in. So what do these values have to do with the graphs? Well, when you graph the equation, r will be the output you're getting, so you don't actually change r. You won't put in a value for it. You'll put in a value for theta and then get the value for r. I talked about that a little bit. So r is a bit, it's like the y value in a rectangular equation. The a value will decide the shape of the graph solely based on its scale. So depending on what the a value is and what the b value is, a will affect the size of the graph, but whether it's positive or negative doesn't matter. Meanwhile, or in contrast, b, the b value that I showed before, will decide the shape of the graph and the direction of the graph based off of the polarity of the b value. So for some examples here, I've forgotten to animate that. For this a value, it doesn't matter if it's negative or positive, it will still give you the same graph. You can see I have 2 different graphs with 2 different equations, but it's the same graph because it doesn't matter if the a value is positive or negative. However, with the b value, you can see that in a positive graph, it's facing upwards. The Limason is facing upwards in the pi over 2 axis, and if we switch the polarity of the b value, then it's actually facing downwards. So with a, it doesn't matter the polarity. You can take the absolute value, and that's all you need to know because it goes in both directions. However, with the b value, that will actually determine things about the graph, so it's important to keep that in mind. And I will talk about how you calculate these values for graphs very shortly. So AB is going to determine the type of Limason you have. First of all, the Limason with an inner loop. That is when the absolute value of A divided by B is less than 1. So when it's less than 1, you'll see that it's got the inner loop here. A divided by B is 1/2, and that's why it creates this inner loop. In the situation where, oh shoot, did I mess that up? I think I copied the wrong thing. Yeah, I reversed convex and cardioid. So with cardioid Limasons, a divided by b will be equal to 1 and only 1. And that creates this sort of heart shape here. And with dimpled limacons, it's between 1 and 2, not equal to 2, not equal to 1. Equal to 1 is cardioid, and equal to 2 or greater than 2 is convex. So with the dimpled limacon, it won't quite bend all the way into the center to create the heart shape you see with the cardioid, and there won't be a loop. However, it also won't flatten out. You can see that near the bottom here, this convex limacon is just starting to flatten out. But there is more to limacons. So, with determining the equation from the graph, let's start with the limacon with an inner loop. As you can see here, this equation, same as the others, but it generates this weird loop in the center. And you can calculate for this by ignoring this point on the pi over 2 axis and just using these 2 points. So these 2 points are 1 and 3. And what you're going to want to do is add them together and divide them by 2. So you're taking the average of them, that is the b value. And the a value is just the distance away of the polar axis intercepts on the sine equation. So that'll be here and here. You can see that both of them intercept at 1. And that's going to be your a value. So that's the equation for the limacon with inner loops. And with these other limacons, you won't actually have that third point to worry about. You just have to worry about where it lands here. So with the cardioids, when you plug these in, with this standard equation form, one of the intercepts will be at the pole, and the other intercept will be at some other location. What this means is the b value times 2 will have the other pi over 2 intercept, which could be positive or negative. And the a value functions the same here. With the dimpled limacon, you won't touch the pole, and you'll instead be a bit out, but you still get that little dimple in here that the name comes from. So that just functions like the cardioid limacon and the inner loop limacon, but without the point touching, and the equation is just the polar axis intercepts for A and the average between the 2 pi over 2 axis intercepts. Now, of course, you have one negative and one positive, so when taking the average, you're going to have, in this particular example, 5 minus 1 divided by 2, which is actually 4 divided by 2, which gets you 2. So that will happen in this particular case. And the convex limacon is the same, just without the dimple. It flattens out near this point instead. And finally, there's circles. Circles occur when your b value is, sorry, not your b value, your a value is 0. And when your a value is 0, your equation is really just b sine theta. And b will determine how large the circle is, while sine theta makes it a circle. So that's similar to these, except one point will start at the pole, and it'll just curve around, and the opposite end that intersects with pi over 2 will be at the b value. So that's all there is to talk about with the equation r equals a plus b sine theta. Thank you.